example that follows, the only obstacle is the root. The example says, root of x is equal to 4. Don't forget that root is another name for fractional power of the unknown or anything else. Let's see how to go about it. Please watch. In this example, we want to learn how to clear roots. We want to learn how to clear square root, cube root, fourth root, fifth root, and so on and so forth. Don't forget that in example H, we learned how to clear powers. Before I proceed, let me inform you that root is a special type of power. Root and power are the same. That word power can cover both of them, but by extension, a root has its own name called root. If we have powers of whole numbers, we could just be called powers. But when powers of the unknown or anything become fractions, then it is these fractional powers that we refer to as roots. If the power of a number is 1 over 2, we call it square root and give it a new sign. 1 over 2 is a fraction. If the power of a number is 1 over 3, we call it cube root and we give it its own special sign, as we may have seen earlier. Therefore, roots are special names, or root is a special name given to fraction existing as a power. Look at this example here. We have root of x is equal to 4. What type of root is this? By now, you should have known that because nothing is written here, what should be there is 2, which means that that is a sign of square root. If it is not square root but something else, the number indicating which type of root it is must be written here within the sign. But because there is nothing written there, by convention, it is correct to write this sign for square root. So this example simply says that there exists a number called x. Its square root is equal to 4. What then is that number? I know that you can guess that the answer is equal to 16. But guess won't always make you go through. Guess won't always make you succeed in getting at the correct answer to a challenge. So embrace logic, embrace mathematical principles in tackling it. Follow me as I explain how to get this square root out of the way to make it just be ordinary x. There are 2 methods of doing that. The first method is that we clear roots with powers. We learned earlier that we clear powers with roots. Now the opposite applies here. The experiments that led to these conclusions are not given here, but if need be, there should be a set of experiments conducted on numbers to show that to clear powers we should use roots, and to clear roots we should use powers. Until then, just take it to heart that that is one of the ways to clear roots. That is to make it raise to power something. Look at this expression, and look at the new expression. Please, what is new? What is new is that this 2 here above was not in the former expression. Why then did I introduce this 2? That was not a part of it before. When solving equation, We can introduce anything as long as that thing introduced is introduced to both sides of the equation. And that is when that thing introduced changes the value of a side of the equation. If I put these two here, certainly it changes the value of this expression. What you think is that the same thing should be done to right hand side. See it here. Why is this 2 here? I ask again. It is because I have learned, and I'm telling you, that we use powers to clear roots. This is a square root, which means that 2 is here. Please, let me show you a formula in symbolic form that we use to clear roots. Okay, please watch this formula. This is something you saw when I was performing operations that lead to the same number when carried out on a number. This is just one of them. If you find the square root of a number and n here, therefore becomes 2, and raise that thing you found to power of the same 2, the answer is that same number. If you find the cube root of a number and raise it to power 3, the result is that same number. If you find the fourth root of a number and raise it to power 4, the result you get is that same number. If you find the fifth root of a number and raise it to power 5, the answer you get is that same number. And in that manner, therefore, this is what we wish to apply here. This formula is what we wish to apply in removing this. This is a square root. How do we get it out? We should raise it to power the same 2, which is here. I think you remember that 2 is here. Because 2 is here, to get this one out, we should put 2 above. That 2 we're putting above is a new thing we're introducing to achieve our goal. Look at that 2 here. 2 is here, remember. It is that 2 here that I mean by this n. X is still there. It is still here. Raised to the same power here, this is 2. The n is now also 2. As a result, the whole expression will give us this x here. Now, this 2 is what is new to left-hand side. The same thing should be done to right-hand side. And see it here, 4 raised to power 2. Because of that, if we simplify both sides, this will give us this x here, and 4 to power 2 will give us 16. Therefore, one way to clear roots is to raise it to power. If it is square root, raise it to power 2, and the root is cleared. If it is cube root, raise it to power 3. If it is fourth root, raise it to power 4. If it is fifth root you want to clear, raise it to power 5, and so on and so forth. This is square root. I raised it to power 2. That's why the answer is this. It has been cleared. Then 4 to power 2 is 16. 4 to power 2 means 4 times 4. It does not mean 4 times 2. All right, second method. What is second method? Second method is to rewrite that square root as power 1 over 2. If it is cube root, we'll write it as power raised to power 1 over 3. If it is fourth root, we'll write it as raised to power 1 over 4, and so on and so forth. So here, this square root of x is what I had to rewrite as x raised to power 1 over 2. After all, I informed you earlier that root simply means fractional power. Root simply means fractional power, or a power which is not a whole number, which exists either as a division or as a fraction. This is a division. This is 1 over 2. It is also a fraction. Therefore, it is this that I have written as x to the power 1 over 2. Then this 2 is the one I'm introducing to make this one become 1. I'm looking for a number to multiply this 1 over 2 with to give 1 as the power of x. Once 1 becomes the power of x, it turns to x, which it has become here. Again, 2 was introduced. It was not there in the beginning. Neither was this also in the beginning. We can introduce anything to equation as long as that is going to help us achieve our goal. If multiplying is what we need to achieve our goal, we multiply. If dividing is what we need, we multiply and we divide. But one thing should be taken into consideration. What is it? Whatever happens to the left-hand side that changes its value must also happen to right-hand side. So bring in any action you want to carry out, but carry it out on both sides. That is a law in solving equations. So this 2 is something new. I want to multiply it with this 1 over 2 to give us 1. Therefore, the same 2 should come here. That is 4 raised to the power 2. The whole of this is x, and the whole of this is also 16. Therefore, the answer is the same, whichever way you see it. Let's see another example that looks like this one. This time around, let's talk about cube root of something. This example, you see, it reads cube root of x is equal to 2. That is a number whose cube root is equal to 2. What is that number? It's okay. Let's try to apply the same methods that we applied before in solving it. But notice that we have a difference in the root. This is cube root and the former one was square root. All right, let us see what we do. The first method is to use squares. The first method is to use powers to clear the roots. That is, clear cube root with power 3, clear square root with power 2, clear fourth root with power 4, clear fifth root with power 5, clear sixth root with power 6, and so on and so forth. This is cube root. So I'm going to clear it with power 3. This is why I introduced this 3 here. I don't think I have to hammer on this again because a lot has been said when I was solving square root of x is equal to something. You remember the way it was done. Square root of x was equal to 4 to be precise. Okay, so what is new is this 3. Why the 3? I have known that it is going to help me to clear this. All right, then this 3 is going to be written both sides. This is 3 here. This is also 3. The next is going to be that if you simplify the whole of this, that is cube root of something raised to the power 3 is equal to x. Don't forget that formula we saw earlier when I was solving x to root of x is equal to 4. All right, 2 to the power 3. Then root of x raised to the power 3 will give us x is equal to 8, meaning x is coming from this expression or this operation, and 8 is coming from this operation. 2 to the power 3 does not mean 2 times 3. It means 2 times 2 times 2. The 3 on top simply tells us how many times the 2 appears when multiplying itself. The 2 is not multiplying the 3. This 2 is not multiplying this 3. Instead, the 2 is multiplying itself, but this 3 tells us how many times it does that. So 2 times 2 times 2 is what this 2 to the power 3 means. And if you say 2 times 2 times 2, the answer is equal to 8. Therefore, if you simplify both sides of this expression, this equation, we get this answer that x is equal to 8. I hope you are following what is happening here. Second method, please. We're going to use the multiplicative inverse. First, we try to re-express this cube root as x to the power 1 over 3. So this expression is the same as x raised to the power 1 over 3. Compare it to the other example where I wrote that square root of x is the same thing as x raised to the power 1 over 2. I believe we can do similar things in future. Now, this is 1 over 3. It is now the power of this x. Meanwhile, what we want to achieve is to get power 1 as power of x. How can 1 over 3, which is not 1, become 1? The only way at this point is to multiply it by its multiplicative inverse, which is this 3 here. 1 over 3 times 3. If you remember the principles of multiplying fractions, you will know that the whole thing will give us what? 1. That will give us x to the power 1, 2 to the power 3 is 8. But x to the power 1 is the same thing as x. Therefore, whether this method or this method applies, the answer is the same. X is equal to 8. Now look out for an exercise. Right, it says using powers and or multiplicative inverses, clear the roots from the following equations. There are only 3 questions here. Number A, square root of y is equal to 5. B, the cube root of m is equal to 4. C, the fifth root of x is equal to 2. Please don't forget that it is safer to apply multiplicative inverse instead of looking for the fifth root of something. Take for instance here, anyway, all the questions this place could be solved either way. All right, please, I believe that I'm going to get the correct answers. That's because I believe you listened to everything I said, not missing out on a point throughout the time I explained what I explained in this part.